Oh, casually watching a video on YouTube on a computer more powerful than anything humanity could build a few decades ago. This progress and all the wonderful machines you take for granted are built on a few rare and precious materials, like names like terbium, neodymium, and tantalum. Getting these materials from the ground into your device is ugly. The mining industry is responsible for air and water pollution and the destruction of entire landscapes. Dangerous chemicals like cyanide, sulfuric acid, and chlorine are used to extract these resources, harming biodiversity, workers, and locals. The rare resources are also political tools when countries restrict access to them to get their way. But what if we could replace the mining industry on Earth with a clean process that cannot harm anyone? Well, we can, and all we need to do is look up. Asteroids are millions of trillions of tons of rocks, metals, and ice left over from the cloud that became the planet 4.5 billions of years ago. They can be as small as a meter of the planet diamonds to the size of entire countries. Most of them are concentrated in the asteroid belt and the Kuiper belt, while hundreds of thousands of more do their own thing between planets. As space travel is becoming more feasible, scientists and economists have begun looking at the resources found in these asteroids. Even relatively small metallic asteroids may contain trillions worth of industrial and precious metals like platinum. And bigger asteroids like 16 Persei could contain each iron nickel to cover the world's metal needs for millions of years. At Connect, mineral prices and rare magnetic materials are also the worth trillions of dollars. Well, not really, but technically. For example, there are more than 20 million tons of gold in the ocean's water, worth roughly 750 trillion US dollars. But filtering out of the gold would be so expensive that you'd lose money selling it. Right now, asteroid mining has exactly this problem. It's too expensive to replace mining on Earth. Billions of dollars worth of valuable resources in space are returned if it costs trillions to get them. What makes it so hard? The principles behind mining an asteroid are simple. The basic idea is choose one asteroid, move it to a place where it is easy to process, and then take it apart to turn into useful products. Unfortunately, all this correlates with fundamental problems humans have yet to solve. Going to space is expensive. It costs thousands of dollars in rockets fuel for each kilogram just to reach low Earth orbit. Going further into deep space costs thousands more. We need to cheaper space travel to make asteroid mining profitable. One solution is to switch the classical rockets to electric spaceships. We already use electric rocket engines for many of the space probes on science missions. In principle, we only need to build bigger ones. While electronic engines are not powerful enough to fly to space, they require only the tiny amount of fuel to go very far once they're in space. That means we don't need to spend a lot of money on fuel only to transport fuel into space. This doesn't solve the whole cost problem, but it makes it easier to start our first mission. Now that we have an electric asteroid mining spaceship, we need to find the right asteroid and get it there. We have already successfully visited asteroids with space probes and even collected samples. Still, to make it easier and cheaper, our first targets will probably be near-Earth asteroids. Asteroids that orbit well near Earth. After a few months of travel, our spaceship finally arrives at an asteroid. Weirdly formed, literated and small impact craters, it has not changed much for billions of years. The first thing that needs to be done is to secure the asteroid and stop it from spinning. There are multiple ways to do this, like vaporing material like a lizard to stopping retaliation of thrusts. Once we have the stable asteroid, we need to wait. Orbital mechanics are completed, so you would push something to the right direction at exactly the right time. You would move very things at very little force. So we wait for exactly the right moment. Our ship fires and transforms and nudges the asteroid into a trajectory that takes it near our moon. The moon is useful because we can borrow its gravitational pull to put the asteroid in stable orbit around Earth, which saves more fuel. Again, the trip takes months, but all the time since our trip is launched, not has been cancelled. The first space mining and processing equipment has been installed in orbit, where it is all carefully moving towards the asteroid. The processor works very differently than on Earth. Great miners focus sunlight and heat up asteroid rock. They boil out the gases. Engines break up and dried rocks into gravel and dust. Commercials suffer dense from light elements. Even if we only extract 0.01% of the asteroid mass in precious metals, this is still several times more than you did from the same amount of ore on the ground. But what now? How do we get our precious metals safely back to ground? There are a few ways, like loading it to reusable rockets, then return to Earth from space. If our processor contains 3D printing, we can print a faster and cheaper delivery system. It fans capsules filled with gas bubbles. We can just then drop in the oceans of our ships, tow them away. This could be the starting point of the humanity's first real steps towards colonizing the solar system. As our infrastructure and experience grows, our missions get more and more sophisticated. Parts and fuel product on asteroids don't have to be launched from Earth at all. The first mining operation makes the second one easier, and so on. While the space industry grows, the precious metals become cheaper. Eventually, we could stop mining on Earth. Even the idea of toxic mining down here might become something weird and anachronistic, like having an open fire in your living room. Landscapes are rinsed away the pollution with care, while the technical wonders we're used to get cheaper and less toxic to make. None of this is science fiction. We don't need to fancy materials or new physics to make asteroid mining happen. We could start building this future today.